what we'll do is well, obviously I'll give like a little brief intro, and then Daniel will explain the tech and probably like a high level. If anyone wants to interrupt while we're talking or anything like that, then just interrupt and ask a question. And once Daniel's gone through the tech stuff, I'll show Taurion. You might have to make my screen bigger if you're recording on your desktop, and I'll show you that live and just go through that. And if anyone wants to interrupt during that, like I might interrupt Daniel, he might interrupt me as well, and then anyone can ask any questions, or maybe Daniel can talk about game channels after that or at the beginning. I don't know, whatever Daniel feels like as well. We've not prepared anything really for it. I mean, we have described this probably like quite a few times. So for anybody watching doesn't know, I'm Andy and I'm one of the founders of Xaya. I've been in blockchain gaming since 2013 when we created Hunter Coin, the first blockchain game, which is a fully decentralized, like an MMO cryptocurrency where players would move around a map and collect coins in this like autonomous world. 90% of the coins were like placed on a map and 10% given to the hardware miners that were mining the coin, and these players would pick these coins up on a map, kill other people, take them to a bank in the game, and then they would appear in your wallet just like as if you'd mined them with hardware. And the players, like in the first month, were taking in over $10,000 a day just by playing this game, and mostly obviously fueled by speculation. But Bitcoin was only around $800 at the time. The game mechanics weren't thought through because it was more about, can we build like an MMO on the blockchain, and is it gonna work? So there was no complex game mechanics there. It was mostly about moving around and blowing people up and stuff like that. So after that, like working with Daniel, because it was like a little bit of a side project or hobby project, even though we put like an absolute load amount of time in it. We came up with some like technologies like along the way, and eventually in 2016 we came up with this idea for Xaya, which was called Chimera at the time, but we had to rebrand it. And yeah, and now we're working on 2 games as well, but without going into those yet, I'll let Daniel explain the technology, what's behind Xaya first.
Yeah, of course. So one of the key features that we want to enable ever since HunterCoin basically, or HunterCoin had that, is that you have like really fully decentralized games. So all the gameplay, all the computation, all the mechanic can be done in a decentralized way. In HunterCoin that was the case because you had a custom blockchain client just for this game. And so it was just like part of the core blockchain layer, just like signature verification and updating to the UTXO set or whatever is part of the core Bitcoin client. But this is in contrast to many of the like current blockchain games that are based on smart contract platforms, or not directly in contrast in this level already. But it is a problem if you build a game on a smart contract platform, because, for instance, if you have one blockchain like Ethereum or any of the others that runs like the game, and you want to put like all your logic onto the core blockchain layer, and you have like 100 or 1,000 games that want to do this, and each game has like a non-complex and non-trivial amount of computations, then it means that kind of the base blockchain layer, like every full node, every miner and so on, they need to calculate not just like one game, as in the case of HunterCoin, but actually for all the games on the platform. And that means that the more games you get and the more complex the games get, the more kind of competition for computation on the network you get. And that drives up, in the case of Ethereum, gas price. And so basically it becomes impossible to do anything like non-trivial fully on-chain with a platform like Ethereum, where you share one blockchain for many games, and you do like all the computations on-chain. So what we came up with, which was in some sense in just an extension of the model that we used for HunterCoin, But it also turns out to be like really useful for building one blockchain platform that is shared for many games, but allows those games to be complex, is this model of GSPs, as we call them. GSP stands for Game State Processor. And essentially, it just means that we kind of use the blockchain for what blockchain is really useful and is really working best, namely to establish consensus in a decentralized, trustless, secure way on essentially the time order of transactions. Because if you think about it, that's actually what the core invention in Bitcoin was. I mean, you can have like signatures to prove that you're the owner of a coin, you spend it and so on. And that's nothing new that was there already for decades. But the core thing that Bitcoin solved was solving the double spending problem, which essentially mean that you have a way to establish a consensus on the whole network without like any central intermediary that tells you like if you have two transactions spending the same coin, which one is the correct one, which one is the first one. So you need to establish a time order. And in fact, I think even the Satoshi's white paper had a section called timestamping or something, which kind of highlights exactly this. So basically in our model and in Xaya, we use the blockchain basically just for this. We have user accounts on the blockchain. We have a cryptocurrency to pay transaction fees, prevent spam, and all that. But in principle, the core feature of the Xaya blockchain, or like the core layer in any system that uses our model, is basically just a way for these user accounts to post data and say, okay, and this data corresponds to moves in a game. So I could post data that says, okay, this is my avatar in this game, and I want to move it from this position to this position. Or I want to post an offer to sell some resources for this price at this point in the map, or whatever. Or these are my tactics for the upcoming soccer game, or anything like that. But from the core blockchain's point of view, it is really just data. So it is really just the blockchain just records, okay, this guy posted with this account, posted this data for this game. And it's signed by his private key, so no one can like manipulate that and impersonate a person. But apart from that, the miners in the core blockchain just stores that data and doesn't really know what it means in terms of games. Because in our model, we decouple the computation of the games and the storage of the game state, which is the costly thing if you have a complex game like Taurion or SME or any other like non-trivial blockchain game. We decouple that from the core blockchain layer, and the computation only happens like on a separate process that just reads the blockchain data, reads the sequence of moves, and then this game state process or this game process itself computes what is the current state, which means that anyone who actually plays a game, they can run that game state processor and compute what is the current state. And then come up with their own view of the world, and they have verified everything by themselves because they have for themselves using their own binary computed what is the state, so they know it's correct. They are not trusting a central server to do it. But if if I play only one game out of 100 on the blockchain on the platform, then I only need to compute this one game and not the other 99. And if I'm just a miner or just a cryptocurrency exchange or whatever, and I'm not interested in a particular game or the assets in a particular game or something, then I don't need to run any of that. So in that sense, we can have complex games. We can scale the platform to in principle, a lot of complex computation without hurting the core blockchain layer, without disincentivizing miners and full nodes to run, and without the need to have high gas fees or anything to load balance that in some way. Yeah, but it's important to note, and I think that's something that we hear repeatedly when we describe our system to others that are not that have not heard about it yet, or that are coming from the smart contract background or whatever. That even though basically the blockchain full nodes do not know anything about the game rules, in some sense, kind of the smart contract of the game, that would be the terminology, it's still like fully decentralized and secure, because we use the blockchain and this core property of blockchain to establish consensus on what is the sequence of moves that happened. So everyone on the whole network, if they want to see, okay, what is the sequence of moves that have ever been made in Taurion, they will get the same sequence of moves, the same data from the same user accounts, because of the way we use the blockchain. But then, like, it's up to them to interpret what does the sequence of moves mean for Taurion. But as long as everyone is running the same client for Taurion and not like a locally modified fork or whatever, they will, because they have the same sequence of moves and the same game rules for the computation, everyone will come to the same game state. So we also have a consensus on what the current state of the world is. Without the need, but this computation is something, the data of the state of the world or whatever does not need to be shared on the blockchain, because everyone by themselves can reproduce it uniquely and know it's correct. So even though the blockchain full nodes and the miners do not actually enforce, that moves are valid, or do not even know what the moves actually mean in the game, it's still like absolutely secure by the same measure as the blockchain itself. That people reach the same game state, and we don't need specific miners for Taurion, for instance, or anything like that, because everyone can compute it for themselves. And even if, for instance, no one is playing a game at the moment and there are no GSPs at all for Taurion, as long the network still carries on, of course. And as soon as the first person comes online again and says, okay, I want to start playing Taurion again, then the GSP just goes there and reads, the sequence of moves, computes the state, and then they will just, compute the update for the last 1,000 blocks or whatever that no one was playing. And it kind of, in some sense, the game world carries on, just independent of how many people are running a GSP. So we don't even have, we don't have an issue that we need to have. We need to incentivize people to run GSPs, for instance. We don't need miners for a specific game. We don't need full nodes for a specific game, because people just do that by themselves.
I think maybe because when I was looking up because we use Xaya, right? But maybe a small concrete example, kind of like you have in tutorials, might help some of the people unfamiliar because they don't know what Taurion is. But maybe like a tic-tac-toe, like an example of how you play tic-tac-toe on Xaya. So that might help for a more concrete for developers thinking maybe coming.
This might help anyway. Is this flipped? This very simple that is flipped? Is it? All right. Okay.
Okay. If you could unflip, that'd be good.
All right. Okay. Flip.
Yeah, it looks good.
Yeah. What I was going to say is like in a basic sense, well, let Daniel carry on as well, but and maybe for anyone else watching, because it's difficult without seeing pictures for me anyway. So like essentially what happens is there's like 3 parts to our games. We've got this game state processor, which is this top thing. We have the Xaya daemon, which is the Xaya blockchain, Xaya wallet or whatever, and then the front end. But what the game state processor does is it reads all the moves in the blockchain for every block and then computes the state of the game. So obviously Daniel's already described that, but I'll just do it again. So like you have your front end, which then sends the moves to the blockchain. What says, right, I want to move here and move there, or I want to send this guy some tokens inside the game, or I want to shoot this guy or something like that. So all those moves go into the blockchain, and then they go into the blockchain. Once they get mined, then the next block that comes in, the game state processor gets all the moves for that particular game and then computes the state of the game, and then relays that in a read-only way to the front end. So then every block we can get the state of the game, and that's it in a simple sense. But anyway, sorry, Daniel.
Yeah, no, that's a very good help, I think, with the diagram as well. So here this diagram shows exactly what I said, that we detach the core blockchain, which is the bottom left red part, Xaya daemon, from the game state processor, the top part, which contains the actual computation for the game, which might be like very expensive. As you do pathfinding, you do like combat on the machine of like everyone playing the game, at least like in a fully decentralized way. And then the front end is just a front end, similar to front ends for Web3 applications or whatever that are typically a website. In this case, it is typically just like another program that you run on your computer that then just talks locally to the game state processor. And one other nice thing, what Andy is putting up here right now is because of also this architecture that we have proposed, that we show in this other diagram, that you can actually build light clients, for instance, very easily. So of course, we think that fully decentralized gaming is what blockchain gaming is really about, but still there are probably a lot of people who do not care about it from the beginning, or who might want to play on a mobile phone or whatever. So it's good to have like these two options, to give people the option to be fully decentralized, to run their own, to verify everything and not trust like any central server. But if maybe you don't want to, or you just want to check like quickly on your phone what is the current state or something, then that you also have an option to choose to trust some server, because you trust the developers, or maybe because you even run your own server, so that you just rent a server somewhere for $2 a month and you run it there. So you are not trusting someone else, but you still have this, you have a server so you can play on your phone. And that's kind of immediately possible with our architecture, because you just move the Xaya daemon and the game state processor, you just move that to some server. And then on your phone, you just have like an SPV wallet, like Electrum. So you keep your private keys on your phone. You're not trusting, like, even in that setup, you're not trusting anyone with your private keys in your money. But you get, the state of the game that the front end then displays on your phone. You get that from the server. So you're trusting the server with the game state. But like I said, maybe people are fine doing that, or maybe they run their own server, or maybe it's a group of friends that trust each other, that just run one server and then use them. Or you could even build a system where you have, multiple of these GSP as a service providers, and you verify them amongst each other, or you build like some system where they put up a collateral, and then you have verifier nodes that check on them and prove if they're lying, and then the collateral gets slashed or something like that. So you can build that if you want to, and you can build like every possible balance between you're just trusting someone for convenience, and you want to verify everything, be fully decentralized. And all this, like this GSP model, I think is exactly what makes the Xaya platform special, in the sense that compared to like games on smart contract platforms, and that allows us to scale in one specific way, namely to scale to complex games and to have many complex games on like one blockchain platform.
Can we ask questions?
Yeah.
Yes, sure.
So when you use libXaya game, are you embedding game logic into the GSP, I guess, instance, or like how does it talk to each other?
So
does it work like a library, or is it like a processor that you embed your code into?
Yeah, so the GSP itself is a separate process that you run that talks using 0MQ or JSON RPC, or like some inter-process communication that talks to the core blockchain node to just get updates on the blocks and stuff like that. And that provides like also JSON RPC interface, or it could be something else as well, to the front end. So the front end talks as maybe it would in a centralized game to the game server. In this case, it just talks to the GSP providing a local server on your machine. And basically, and as you say, that the GSP is what contains the core game logic. But the role of libXaya game in this case is just it's just a library that you use to build this GSP, and that does like all the blockchain parts for you. So it establishes the communication to the blockchain node, and it it manages like what is the current block and stuff like that. It stores the state. It handles like if the block gets detached and another one gets attached, it handles that for you. So that you really just have to, as the developer, you really just have to basically provide one function that says, okay, here's the current state, here are the moves from the current block, use your game logic to compute what is the new state. So libxaya game is a library that makes it easy to build this GSP as a process.
Does frontend talk directly to Xaya Daemon through RPC?
Yes, it does. Namely, I mean, it could also talk to it to just get the current block or something to verify if the GSP is on the same block height and show like some statistics. But the main way that the front end talks to the Xaya Daemon or an SPV wallet in the case of mobile gameplay is to do like to actually do stuff that involves the wallet, namely to send a move. That's the main thing.
I just have one more question. Sorry. Go ahead.
No, go on, Kijun, go on.
Just a quick question. So this is based on Bitcoin, right? Xaya Daemon?
Yeah.
What happens when I guess like the chain reverses and you have you kind of have to go back to another fork, like longest node? Then how does game state processor handle that? Like I mean we've been thinking through this problem in the planet side too.
Yeah, I mean, that is exactly one of the things that libxaya game basically does for you. So the game developer doesn't need to think about it. But essentially what it does on a low technical level is that it works very similar to Bitcoin. So it basically the core daemon tells it, okay, so this block got actually detached again. So you have to undo this block, which contained these moves.
Right.
And the game state processor, I mean, the moves themselves might not be enough to compute, what is the previous state. So the game state processor can also store like some extra data that it needs to undo the data. That's exactly what Bitcoin also does. If you spend a new TXO, then it records some undo data for that block. So which is exactly the data it needs, so it can compute from the new state plus the undo data plus the moves. It can compute the previous state. That is the core model. And in this sense, the game developer actually needs to implement two functions. One that computes like from old state and block, computes the new state and the undo data, and one that computes from new state, undo data, and block, it computes the previous state. However, we also have, and what we actually use in most of our games is kind of a bit more like a bit more higher level, that the game state is not just some raw data, but we actually use an SQLite database to store the game state, because that makes it easy to have games that have like gigabytes of game state if they want to, and need not pass it around all the time. And if you actually use that model, then libxaya game does all that stuff for you, because it just uses some SQLite functions to actually record the delta kind of that you applied in your game logic from old state to new state, saves that as undo data for you, and then it just kind of reverses the delta to get back to the old state.
Something on that as well. Something on that as well. Not as technically advanced what Daniel's talking about, but you can actually use that function for undo data as well to rewind the game as far as you want. So if you're recording all the undo data for the entire game, you can say, right, what happened at this block, and then you can actually reverse time, but you do have to compute it in, like, it is slow to compute it, but you could say, right, who killed me last Friday? So then you could just zoom all the way back using this function, what is in there, to handle the reorgs, and then go back to the current block. So you can actually use it for more fun things as well.
Yeah, I mean, we are not doing that in our front end at the moment. And as Andy said, it is some computation, and probably you would want to store, some checkpoints or something if you want to have that as a real function. But maybe, a block explorer for a game, or like a web, the game developer could launch a website for the game where they would store some more data, where they provide this, that you can go back and forth in time. to kind of really step through frame by frame in some sense through the game world, can figure out these things if you wanted to. And it's technically it's possible. It's just something we have not implemented so far because it's not as important as other things.
Yeah. Awesome.
Yeah, I was thinking. So, hi everybody. Sorry, I didn't say hello at the beginning. I had my kids with me, so it was a mess, noise in the room. So yeah, so it's very interesting architecture. As you know, I'm a fan. So the question I had, which I asked you before, is when you have multiple gamers and some gamers are pretty active, some gamers are not that active. The people who are not that active still have all the moves, and how much of the like do I as a casual gamer have to compute as much as to get to the state of the world so I can play my part as somebody who's a hardcore gamer? Because then what happens is it's kind of a dilemma that I want to play the game, but because there is no like miner or validator who's doing all the state calculation, each person is doing, it might be a lot to ask for casual gamer, or is there a way to incentivize them?
Yes, I mean, so of course, like you said, basically everyone who wants to have the game state and have it like fully decentralized, verified for themselves, they have to compute the state. Just like, you know, if I want to run a Bitcoin full node, even if I don't do any transactions, I have to compute all the state, so I know it. But of course, it then depends on the game and on the concrete situation, whether that's a problem or not. Maybe a game is easy to compute anyway, or maybe it's not. But if you have a really complex game that would be like too much to think for a casual gamer, and the casual gamer doesn't want to do all the computations because it would be too much, then you always have the option of just letting them connect to a server if that's fine for them. Or maybe they just, like I said, they just if they don't want to trust anyone and they also don't want to compute it on their laptop or whatever, then they can just rent the server for $2 a month and run the GSP on there. It's always on, so it always stays up to date. And whenever they want to play from their phone, they can connect to it. Or maybe, like I said, also maybe a group of people who trust each other, who play the game together. Maybe they just do that together, run one server that each of them use. Or you could come up.
You also a server. Could there be a slashing mechanism of in-game currency where the server would put a stake and then the game would,
Yes, that's what I meant with this kind of balance between convenience and trust. You could certainly do things like this server that you talk to, they kind of answer your queries for the current state, and maybe they sign it with their private key. And you could, for instance, just add to the game rules themselves a function that says, okay, if you send a move that provides, like a signed answer from some guy running a server, and that answer is actually not correct, then you get part of their in-game currency. That's something that you could just do by extending the game rules. And also we thought about, ways to build like a more general system where you could run a 2-bit like verification system, maybe using Cartesian VMs or something like that, where you could then just on that system provide, proofs for like wrong answers for GSPs or whatever, and use that to build like really a validation layer. So it's possible. It's just something we've not yet done as well because of priorities or whatever.
Yeah, I think it's. Oh, sorry, go on. No, go on.
Yeah. Okay. Yeah, I was just wondering, like, if you thought about like a super GSP, because one issue I can see is, like, as mentioned on Discord, is that you don't have interoperability between games. But what if you had a GSP that the game are actually implemented as script inside the GSP?
Yeah, you can definitely. I mean, in principle, you can of course do it. You could even have a GSP that just runs an Ethereum EVM or whatever. But what we were more thinking about is that you could have a GSP that allows, running Cartesian VMs for 2-bit verifications. And then you would kind of just use those Cartesian VMs to prove that another GSP that just runs inside the VM like prove the state somehow, like someone lied or whatever. And it exactly like you said, one could like build kind of a master GSP that just has this Drubit Cartesi layer in it. And then you could use like have an in-game currency in that GSP that you use for staking and use for slashing.
You mean you can have something like either a very simplified way where Ethereum does, where it basically markers all of the state, or something like Truebit, where it basically kind of does the computational, like the tree of the execution tree, and you take which basically leaf you want, and you like a map reduce kind of thing, but not to distribute computation, but to like be able to have verification on which part of computation is wrong or right. And that would be interesting actually. If some people start having a kind of a new model of business where they say, hey, I will do that service, where I will provide the latest state and I will provide the kind of tree. And if enough people provide and they put collateral, then even a casual gamer, all they have to do, or a mobile gamer, they have to just maybe check the market or the kind of basically the roots of some tree between different.
Yeah, exactly. So I think there are basically two ways in which we could build like this slashing, staking, validation system to get more trust into remote GSPs. One is just do it inside a particular GSP that just needs, some very basic additions to it in some sense. But then like, every game that wanted to do it would have to do it for themselves. And the other would be like this master GSP, which I think would just probably use a Drubit type system, but in any way it would just embed some kind of VM or scripting or whatever, where you could then just run kind of any GSP, or maybe just like some, if it follows a certain standard, but whatever. In principle, you could run other GSPs where the game developers themselves wouldn't really need to think about it themselves. And both of that is absolutely possible. It's just something that needs to be implemented.
And as well, although the interoperability in the way that it is now might sound like a real major disadvantage, but it also depends if you believe in these multiverse of items is actually something useful. I personally myself, I don't see how it would be advantageous or very advantageous to be able to use a sword in one game and then in another game. I mean, why would different developers work with each other? Now, it does have some advantages, but I think it's not something like a major thing that we should be working on now, personally. I mean, you can also as well sell a sword in one game for like Chi, the cryptocurrency, and then buy another weapon in the other game. So you can go in and out of games that way, but not trade my sword for an item in another game. But you could also just use a centralized server for that, and that's what you could do. Sorry.
I just wanted to say, I think it's more than a cross game. I mean, for example, on Ethereum, what we see is that you can have a loan based on an NFT that you earn in a game. I think it's more about a cross ecosystem thing. It's not necessarily about using an item in another game.
There's definitely some.
That's a marketing thing. So, do you guys have so far some external developers kind of starting to use Xaya for their own games?
Yeah,
is that a major use case? Is it a main use case?
What do you mean? Use case for cross?
No. For Xaya generally. So basically, you take my impression is it's a gaming platform. So the main customers, the main users should be other game developers who are using Xaya to put their game on a blockchain. Correct?
Oh we want them to do. Yeah, I mean, we don't make any money from that because the Xaya blockchain is all completely open source and free. So anyone is able to work on it, and we want people to as well. Cody, who is in this call as well, is actually building a couple of games on our platform.
And what does the process for it look like? I mean, how easy or difficult it is to do that? I'm just thinking, for me, there's millions of game developers, mobile developers, and so on. So for them, something like turnkey solution. Here, you can make your game a blockchain game, and it would benefit you by people getting the tokens or whatever the economic effect and or
Yeah, I guess
community.
it depends what sort of game you want to build. I mean, if you just want to use a blockchain for like NFTs and assets and things like that, probably better with the Ethereum ecosystem and maybe using that. But if you want to build a complex decentralized game, then probably there isn't anything else out there, I think, where you would be able to do that easily. Maybe Planetarium as well. Hopefully we'll have a call about that next week or something. But Cody, I don't know what your experience is, and I'll give you some money later.
Well, we were not going to do a blockchain game because it sounded like really, I didn't want to learn Solidity. I knew JavaScript, but I didn't really understand the smart contract system in the first place. So we were initially thinking, let's just go the virtual coin route, like a engine or whatnot. But then we ran across a Taurion demo, and I started to dig into it a little bit. I actually have, when Kijun was asking questions, I brought some of my code up. But it's actually pretty, I like to think of it as, say we're playing a chess game, right? And we're playing over email. We both have our own board, and we have our chess pieces set up. And then I send you the move in the email, and we all update our boards at the same time, right? So we're like, oh, okay, this is the move he made. So if someone knocks over my board game, I can just look through all of the email and then just reassemble the pieces in all of the moves that they did, because we all know the same rules to the same game. And that's kind of what it is. But instead of emails, it's JSON. But let me see if I can share.
Good. Yeah, I wouldn't want to play chess via email.
As well, just to say, we don't have a lot of time left, so like try and make it quick, Cody, because I want to show some Taurion, and we also haven't talked about game channels as well. But which is always special ability, even though we talk about this GSP stuff.
Real quick right here. So this is just the main what Daniel was talking about, one of the forward calls, right? So basically, you just make a callback, and you put in the Xaya library, gives you the current state of the game in a string, and then some of the other block data. And then what we do is we initialize a class, and then we put in the we just put the state in there, right? We deserialize the current state and initialize the class with it. And then essentially from there, all you're doing is whenever you see one of these JSON commands, if you say, let's see, where's my, so here's all the names in the data, right? So if I see, I deserialize my actions to a class, so the action class, and if it sees the IG buy, then that means player's going to buy something, and then I do that function in the processor, right, the state processor. And that's all really it is. You're just deserializing a bunch of JSON data and then doing something with that data. So
okay, so I'll so what I'll do now then is I'll just show some Taurion and try and go through it like pretty quick. Maybe we don't have time to speak about game channels, but we can go over the hour if we want to. But if people don't want to stay, then that's fine, whatever. So I'll just click this off. Hopefully, I click the right thing, not some porno or something. I'm only joking. Right, so so this is like Taurion inside this Taurion world. Basically, it's an MMO RTS, or like a bit like an RPG, you could say. It's a completely persistent world. Basically, there's 3 houses or 3 factions that have come to this planet for like fighting over resources. We won't get into all the story. When you join the game and you choose your faction, you're like a commander, and you can control units, of which you can have a maximum of 20 per account. And like your units are different, like vehicles and things. So there's loads of different vehicles in the game, and all the different factions have different vehicles. The map is I'm going to do this pretty quick as well. So the map is made out of hex tiles, and there are 65 million hex tiles, and each one of those hex tiles can be moved on and walked on. Again, it's all like completely persistent, like sandbox world. The vehicles you move just like you can in an RTS game. I'll just do that. So I can select it, click there, something like that, and then press this go button. So the moves like happen every block, which the blocks are every 30 seconds, which like does seem quite slow, and the first one might take a bit longer. These purple lines here are a pending move. That means it's in like the memory pool now. So if somebody moves, you can see that instantly where they're going to go. So although it takes a long time to move like this now, we have got in the roadmap to make it so when you do move, it will move straight away in the front end, and that can just be done by creating an illusion and estimating how long it takes to go to these different waypoints. So we can make it be like completely smooth. The graphics as well are like pretty much placeholders, so ignore that the graphics like don't look like too great. The map as well is split up into these regions, these red regions. So there's 650,000 of these regions, and each of these regions can be prospected. So if I select this one, prospect. So when you prospect, when that one gets mined, that one will do a countdown from 10 and then tell us what is in this area, and it will tell us either what resources are in this area, if you can build a building there, and also you've got a chance of finding an ancient artifact. This is all in an alpha, so at the moment it will only tell you what resources are there to mine. Let me just go. Yeah, so like what you do when you prospect these resources. I'm just looking for somewhere I've already prospected, but I haven't. So what you do when you've prospected and you find out what resources there, you can then mine those resources, which then fills up your inventory. Again, excuse the UI, as I say, the contrast is like it's still in work in progress. But when you mine these resources, they fill up your inventory with these resources, and then you can take those resources to a refinery, and then they can be refined into all the materials. And there's 9 different resources you can mine, and then you can take them to a refinery, refine those resources, and then with the refined materials, you can use them for construction of like other vehicles, upgrades, and there's like hundreds of different upgrades, like 30, 40 different vehicles. All the vehicles have like these different slots for like different turrets, so you can have AoE damage weapons, missile launchers, what like attack someone within range and then does an AoE around that. Weapons what slow down the enemy, reduce the range. You have all these other engine slots as well, which are for increasing the speed of vehicles, shield replenishment rate, electromagnetic warfare weapons, and then structural slots as well. So if you've ever played EVE Online, it's the same sort of equipment layout upgrades as EVE Online. So again, this is all fully decentralized. We have, like Daniel's already done most of the weapons and stuff in there. There's different buildings, which each building has a decentralized exchange in them. So you can buy and sell stuff from anywhere on the map. But you'd have to go and collect whatever you buy from those buildings if you need it somewhere else. So it might be you need to. Did you make my screen big, by the way, Ed? Hello?
Yeah, sorry. Yes.
Okay, yeah, that's all right, brilliant. Yeah, so although you can buy from anywhere on these decentralized exchanges, like each building is one, and you need some resources at one place, it could be that those materials are at the other side of the map, that are more abundant there. So those materials might be 10 times more expensive to buy them somewhere close, but it's really cheap far away. But that might take you 2 weeks to cross the map in a big industrial vehicle, like 2 weeks of real time. So that creates like this supply and demand, and then also opportunities for people just to do trade, just to do transporting goods, or they might just want to do crafting, or they might just want to attack other people, or all that sort of stuff. So like a lot of the stuff has been just to show you the size of the map as well. So it's like pretty big. But so like most of the stuff has been implemented now in the game state processor. What Daniel's going to be working on next, after he's just finished adding these extra weapons, is like character skills progression and things like that. So each account gains skills in mining, crafting, building, and all that sort of stuff. The buildings are in there now, so like if you're on the map like this, you can go in a building, and then when that gets mined, he'll go into the building if it's within range. Once he's within, I think it's something like 14 blocks, so I can't remember what it is. That will go in, and he can go in the building and then use the building's services, because each building also has services. So you have like refinery, construction facility, research facility, repairing, and all those services are all integrated now in the back end. But a lot of the work is actually the front end as well. So although Daniel is, the master at developing all this in the back end, the front end as well, which Constantine does with us, is probably double the work as well. So that's like a lot of the hard part there. There's different types of buildings as well. Like, this is an ancient building. Whether these will be buildings in the full game, we're not sure yet. But player buildings, ancient buildings can't be destroyed. So if you have any assets in there, they're completely safe. But if you're in a player building, like this is one, but this is just like an example one. If you have assets in a player building, they can be destroyed. So they're not actually safe in there. So you better make sure it's protected. If you have a player building as well, you can set the fees for things like the people using the refinery, and you can have different fees for if someone's in your alliance. And you can also sell ad space as well above your building. So you can have like an ad, you could have the Sandbox or FT Pool or Ubisoft or whatever. But yeah, there's a lot more like to the game as well. Like say alliances, a reputation system, and some other things. And I think, can I just show you this? Yeah, these are just like some of the recent like things that Daniel's just added in recently. I mean, there's a lot of stuff before this, but we've added like just recently buildings, so you can enter and leave buildings, inventories in buildings, so you can drop things in buildings. That's all implemented. Combat with buildings, so buildings have health points and shield. And so the vehicles as well. They have like shield replenishment rate and stuff like that. So vehicles can be destroyed and buildings can be destroyed. There's implemented refining, repairing, the fees, and there's blueprints as well. So, like in a lot of MMOs, in the year 2000, for probably about 10 years, made a living like buying and selling virtual assets in like MMO RPGs and things like that. And like assets had value then because of the utility. People always would pay more for like the most damaging sword, the best DPS sword in the game, because then that means they can get more items, because then they're harder in the game, they're stronger. So in this game, if you want an asset, you can't just buy it from a dev store. You need to get the materials, refine them. Oh yeah, something just happened in the game. I'll show you that in a minute. So you need to like get all these resources, put them together, find somebody with a blueprint, construct them. So it might take you 3 weeks to get a missile launcher, and then somebody can, who wants to buy one of those can say, right, do I want to spend 3 weeks getting this missile launcher, or should I just pay this guy $50 for the time that he took to do it? And the other guy might sell it because maybe he's got an upgrade, so he's not bothered about selling 3 weeks of his time for $50, or maybe $50 is a lot of money for them. So it's all like completely player-driven economy, and work is involved to get these assets. Just like mining Bitcoin, you need to put the work in to get the coins, and this is just another way, like using skill and intelligence and teamwork to be able to get these items. But yeah, so there's blueprints in there which you can. When you prospect a land, you can have a chance of finding an ancient artifact, and you can take an ancient artifact to a research facility where it can be reverse engineered, and if you're lucky, you get a blueprint, and blueprints are used for construction. And you can copy blueprints into single charge blueprints for other people to use. Construction facilities added, and a lot of other things as well. So that's like where we're up to with it. But I was going to show you as well. yeah, so we run some competitions in Taurion as well, where just to like get people testing. And when you do a prospect, you had a chance of finding some prizes, and you could find like $1,000 prize, and this was all provably fair. Now it wasn't trustless in the way that it did automatically get paid. We had to manually pay them. But for games in Taurion itself, it is all provably fair, the game, and everything is all fully decentralized and censorship resistant and permissionless. You know, anybody can get in this game. And when I did that prospect before, I did find a prize, so I just wanted to point that out. So that is essentially Taurion. Hopefully, didn't bore you with that. So I'll just put that back on. Yeah, so that's that. So if anyone's got any questions on that, or if not, then we could go into game tells, whatever. Yeah, go on.
I have a question about is all the landscape on the train landscape data, the geometry? No. Yes.
No, just the state just includes like the positions of all the vehicles, what's in their inventory, where the positions of player-made buildings have been placed. And so it's
okay.
The front end isn't on the blockchain basically.
So if I am a player, and may I change the geometry of the landscape? Is it possible in this game?
When go on, Daniel.
Yeah, so I mean, one thing that Andy said, like all the kind of just the graphics, like is there a mountain, is there a quicksand, whatever, that's just in the front end and doesn't matter at all. But of course, what does matter is, like you said, can I walk on this tile or not, for instance. And this data is something that is not stored on chain because it's just part of the game rules. So it's just part of, if I download the Taurion GSP, just like the rules of the GSP say, okay, you can actually fight other people or whatever, the rules just include, okay, this is the map data. And as long as I use the same map data as you, I get the same state as you. Of course, I could change it locally, then I would get a different state if I want to do that. But then I end up kind of on a fork compared to everyone else. So if I then, mine resources or whatever, using my reality, using my modified data, I couldn't sell them to anyone. So why would I do that? And no one else would be kind of harmed by me doing that.
Yeah, I know. Yeah.
Andy, do you want to show him the move that you just made on the Xaya Explorer so they can kind of see what the move data looks like? Because it popped up on the Explorer, the move you just made in the game.
Oh, yeah, I can do that, I think. Yeah, so that was just the move there. That you mean?
Yeah, but like explain like how you guys tear it apart.
All right, okay, yeah. So when you do a move, like the Xaya blockchain is based on Namecoin. We said Bitcoin before, but it's actually based on Namecoin, which is based on Bitcoin. And there are like different RPC commands or operations you can do on the Xaya blockchain, and one of them is where you can register human readable names, and what's what we use as accounts. So my account there is called Akalos. We put a P in front for, I guess, stands for player. Is that why we put P, Daniel? But anyway, yeah, so we say P/Akalos is my account there. And you can do an update of this name, because I'm the only person with this name and the private key. I'm the only person who can do this, who can modify this account. So I can update this name and then put in the move in the blockchain, and that is just my move, just some JSON for like some waypoints, and like G stands for which game it is I want to interact with this account. TN is Taurion. C is the character I want to move, and this is character 2073. And the action in the game here is like some waypoints. So there's that there. And EB, what's that, Daniel? Is that for intent to go in a building?
Yes, exactly.
Yeah. So that's to say to go inside the building.
Okay.
That's
cool.
All right. So yeah, so it's gone an hour. I don't know what if anyone wants to do. Obviously, we didn't get a chance to speak about game channels for real-time gameplay, but we could do that another time if you wanted, if you needed to go, or if anyone's got any questions or whatever.
I'm still around. If I could crack on for a little bit longer. I guess it depends on consensus if everyone wants to stick around, if they can stick around. Another another 20 minutes or something, or whatever it takes. It's okay for me.
I can stick around.
Me too.
If some of them can, then that's fine. We can record. It's still recording anyway, isn't it? So, all right. Did you want to just do a little bit of game channels? I mean, I have got a game, but no, it'll take too long to set up now. But anyway, go on, Daniel. Go on.
Yeah. So basically, the idea of game channels, or like what it is about, is kind of improving scalability orthogonal to like the GSP model. The GSP model is for scaling to complex games, many games on a single shared platform. And game channels, on the other hand, are a way to improve scalability within one game. And basically, the idea is very similar to payment channels in Bitcoin, for instance. And it's just okay, we could have we actually have built that game. You could have a GSP that allows players to play battleships against each other, or it could be chess, it could be whatever. And maybe the wager and the winner gets something. It could be a trading card game where the winner gets to choose one of the cards of the loser or something like that. But then the core idea is, if you have a game where you have this like interaction of two players, or could be could be 3, 4, 5, doesn't matter. But in principle, these two players just play against each other, and then the winner just gets some money, gets some high score points, whatever. Then it doesn't matter for everyone else on the network to see like what exactly happened there, as long as the winner can be sure that the other guy cannot cheat. So the winner can be sure they can prove that they won, so everyone can then know that they actually won the card or won the money or whatever. So using game channels, you can just do that. So two people, or like I said, could be 3, 4, 5, can open kind of a channel between each other by sending a move to the blockchain that kind of contains this intent that, okay, we want to start a channel. These are the people with these public keys, whatever they use for signing, and that moves also includes, okay, we play this game for that amount of money. That depends on the GSP itself. But then the interactions on that game channel, they just happen off chain by just the two people just send their moves to each other, sign the current state and their move or whatever with their private key. So so that in principle, if I'm playing against some other guy and the other guy stops responding, or I win the game, but the other guy refuses to send a transaction on chain that sends me my winnings or whatever, then I can go on chain and post okay, here's the other state of the latest state signed by the other guy that shows that I won. I can just post that, and then the network can verify that I'm right and I get the winnings nevertheless. But in the hopefully typical case that the people are just running the official client and not trying to cheat, to modify, whatever, all those moves in between need not be recorded on chain. They also don't need to be confirmed each time. So we could send like very many moves per second between each other if you want to, and if you have enough bandwidth and fast enough computers, whatever. So you can use these game channels essentially to have real-time gameplay, or almost real-time gameplay, where you don't need to wait on block confirmations, and you have you could have many channels open with hundreds of moves per second on each channel. So in principle, you could have on the whole game world, you could have hundreds of thousands or millions of moves per second if you wanted to, without the blockchain being kind of the limiting factor. And also without, that the people have to pay transaction fees for each move that they do very fast. That's kind of the core idea. And basically, we have implemented a framework that does all that for you, similar to libxaya game. So basically, if you want to build like a game channel game, then you more or less just have to, again, fill in what is my actual logic of the game, in the same sense that, okay, here is an old state, and the other guy just sent a move, and the framework verifies for you that it's signed correctly and everything. And you just need to say, okay, applying this move to the state using my game logic, like this is the next state. And with that, we have built one demo game, which is called Xaya Ships, which, like I said, basically is just a way for two people to play battleships kind of real time. I mean, it's still a turn-based game, but the moves can be, like every second or whatever, depending on how fast your opponent reacts. That's what Andy is going to show now. But we also have designed a way that you can actually use these game channels, for instance, to build a game that looks and feels like a real-time game. Like it could be really a racing game that is just like a continual evolution of a world using some physics, and with only some very limited restrictions, which you obviously need to have because you have some latency between the players and so on. You need to sync them up. But apart from that, it really is a full real-time game, but it's still like fully decentralized, kind of real blockchain game in some sense. You're not using a central server. You're not trusting anyone. You can do that. And also you can use game channels, for instance, if you have like a world like Taurion that grows and becomes bigger and bigger. What you could do is shard the world in the sense that, okay, if I and 5 other people are in that part of the world, then we actually just open a game channel and we do computations for that part of the world on the game channel. And anyone else who's not in that part of the world doesn't need to know the details. They only need to verify maybe that a total of this many resources gets dropped there, and how these resources get distributed between us 5 doesn't matter to the others, so that can be on a game channel. And this way you could have worlds even bigger than Taurion, even more complex. But that's just an idea for now.
Yeah.
Okay,
So
quick question, sorry.
Oh yeah, cool.
Can you do multi-party game channels?
Yeah, of course you can. Like I said, you can have 3, 4, 5. The framework supports that, the underlying tech also. What is kind of the restriction, at least in the current way it's implemented for now, is that if you have very many people, like 100 or so, then it becomes slow and inefficient. But then it's up to the game to make use of that. Maybe you structure the game that you need only 3 or 5, 4 or 5 anyway, or maybe like that's an idea that Andy had. You could still build, a game where, for instance, 2 teams play against each other, where you have 10 teams of 10 and 10 players versus 10, and you just do that by having each team trust one person, and then in a sense it's just a 2-player game channel, the teams against each other, but it's still 10 people that actually take part in the actions of one team.
Yeah, and in like esport games, like League of Legends and things like that, you do trust your team because you're playing, in like a tournament or whatever, so you are a party. But yeah, while you're talking anyway, if there's more questions, like I'm just playing the video in the background on my screen of Xaya Ships, this one is turn-based, but it is like a demonstration we've got of this game channels where it is completely real time. So as soon as you click on to do a move, it instantaneously, well, like depending on how long the network latency is, the move appears on the other side as well. But anyway, yep, sorry.
I think that was the basics anyway. So
yeah.
I mean, of course, that's just like what it is, not how it works in detail and so on. But I think that's the main thing to mention here.
Yeah, there is a paper what has been peer reviewed as well. Where you can probably just Google game channels Daniel Kraft, and that'll probably find it. Okay, anybody else got any questions?
I do have, because we haven't done a game channel yet, right? Yeah, that's going to be our next one. So I'm still a little bit foggy on how because the game logic, obviously, like you've said, is not on the blockchain. So I'm a bit foggy on how the game channel moves are reflected in the main blockchain. So how do you get the end result to like maybe a larger GSP that just monitors the high scores or something like that?
Yeah, so you still, in a game channel game, you still have a GSP in the traditional sense, and that also needs to know about your game logic, of course. So you probably just write the game logic in some class, and then you use it from the GSP and also for the channel itself, or something like that. But in principle, the GSP for a channel game, for instance, for Xaya Ships, it handles moves just like in other games, but these moves, in the case of Xaya Ships, for instance, they are just open a channel. So I send a move, and Andy sends a move that we want to open a channel with each other, and then the GSP verifies that and records, and in the GSP on-chain state, okay, this channel exists, but you may not know what is the actual configuration of ships or whatever, because that's taking place on-chain on the channel. But if then we are finished with the game and Andy won, for instance, then in the ideal case that there is no one trying to cheat, whatever, then I just sign a message that says, okay, on this channel Andy won, and I've signed that, so kind of it's fine. And then Andy just sends that in a move on chain, and the GSP just verifies my signature and says, okay, this is the public key that opened the channel, and he signed it, and so it's fine. So he gets like a point or gets the money, whatever. But of course, also if someone tries to cheat, or if I just stop responding, if he won rather than sign the message, then Andy can also post on the GSP on chain a move that says, okay, here's the latest state that I signed, and here's my move, and then if we apply this, it means I win, for instance. And then the GSP kind of just verifies the signature on the state and just replace one move or something. So the GSP needs to know the logic, but it only needs to apply it selectively if there is actually a dispute and the move is sent for this dispute on chain.
Okay, so you're not packaging all of the moves then sending it at the end.
I mean, in principle, that's up to how you want to design the game. So it could be that for a dispute, you package, you send a sequence of all the moves and you verify them. But it's probably better, and that's what we do in Xaya Ships, that you just, that if I make a move, I not only send my move to Andy, but I also sign the current state and send it to Andy, so that you kind of have like a semi-recent state signed by both people. Right. And then the GSP just says, okay, this is signed by both people, they agreed on the state, and then they just apply the moves on top of it.
Okay.
It may depend on the game, maybe in a game the moves are really cheap and the state is really big, so maybe in that sense it makes sense to actually send a sequence of moves. Depends.
So, but yeah, if going to say quickly, if for example it's a real-time game where you're moving around, like first person or something like that, then you'd, like Daniel said, you'd sign the state, and the state could be like your XY position on the map, how many health points you've got, and then if then it's easier, like what Daniel said, rather than sending a lot of sequence of moves, it's easier to prove if they just signed that they had 1% health left, and then you can say you won because you fired this spell, which then made him have 0 health.
Right. Okay, so the key to the game channels then is getting both players to sign the end state and then submitting that state. Okay.
Yeah, or an intermediate state like the last one they agreed on, and then just the moves building on that to prove if the other guy doesn't respond anymore, to prove that you won.
Okay. All right. Thank you.
So in that case, when you submit it to the GSP, you say get out of the channel and when there's a dispute, because you keep signing the state, so the GSP doesn't, like unlike a Lightning Network, the GSP does not have to wait for a certain time for the other person to respond. Right?
Well, you kind of have to, because there's this one thing. If the other person stops responding, then you kind of you need to be able to prove that, because otherwise, I could just go on chain and say Andy stopped responding, so I win. So you need to put that kind of on chain first that I claim this, and then Andy has, you know, like 5 minutes to respond and say, actually, here's my next move. So I responded. And only after 5 minutes or whatever, then the GSP would say, okay, he really didn't respond, so I win. But you don't need to wait, you know, like days or something.
How long do you wait for your...
That's, I mean, you can decide how you want to do that, because you just need to strike a balance between, you know, making it short enough that it's not an annoyance, or not as much an annoyance as, or as little as you can, but still giving the other person a chance to, you know, respond if they're actually still there.
But yeah, so
a
like
couple of blocks probably.
But yeah, but the obviously maybe what you're getting at there as well is that can be a pain for a game. So if you're playing like some real-time game and then someone just is a dispute, it's gonna like really interrupt the game. And Daniel's come up with something called ephemeral timestamps, which means really you only need to do that once. Someone can't keep.
Yeah, I mean they solve part of the issue. They solve the issue that, you know, if I'm like hostile on that game channel, then I could start putting like every move on chain, starting a dispute all the time, and the other person has to, you know, pay transaction fees all the time to resolve it. And ephemeral timestamps solve that, so that you don't need to pay, you know, transaction fees all the time, for instance, and don't need to actually bloat the blockchain all the time. But they can't really solve this issue about delaying the game, because there's just nothing you can do about it. You need to be able to, you know, prove somehow that the other person didn't respond, but you sent them your last state. And there is really nothing you can do there to do that, except for, you know, waiting. But of course, if you have a game like Xaya Ships or a racing game or whatever, that's PvP, then if someone just does that all the time, like does a dispute and delays the game all the time, then I may just not play against them anymore. And,
yeah, so you can keep track of how many, if somebody keeps doing disputes all the time.
Yeah, so you cannot lose money through that if someone tries to cheat, but they can annoy you. But then you just finish that one game, and then you don't play them anymore or whatever.